Okay, I'm going to get started again. So this is Cam Studio, so I'm trying to do a screen capture for the first time because it's in Excel and it's hard to use and hard to see. So I will post this now so Roy can watch this, or you can have this to refer back to. This is Nick's spreadsheet. That is correct.
I realize I have some blanks in. Yeah.
You have a couple blanks, not that many. You did a fairly good job, which is why I'm showing yours. So you notice that he has DP5 selected for all of these. I know for a fact that that's not true, but they're all in yellow, which means he's still working on it, but this was his best guess for the time being. Also in here in yellow, he's got his other guesses that he wasn't sure, but this is what he kind of thought. And that's what I had wanted. I wanted this all filled in, and if you didn't know the information, to take an educated guess and just highlight it in yellow with the thought that hopefully we'll get back and take a look at it. Okay. The reason we went this way, if you remember, there's a couple reasons, and we talked about this last Tuesday, I guess it was. We could have done this a number of different ways. The reason we went this way is such that we could have all the information on one spot, so that when it comes to determine your panel, when you get your dent data logging, well, I can take all of this equipment now, and I can go like this, and I can go data and sort, and I'm going to sort by, well, I'm going to sort by panel when I get there, but let's say we're going to sort by category at this point. So I sort, come down here, click category, hit OK, and now I've got all of my equipment sorted by process, lighting, HVAC. And I can do the same thing for the panel. So that's really going to help us once you get your dent data logging. And that's the key difference why we did it this way instead of using the tabs along the bottom, is such that we could sort by panel. Okay. Now, knowing all of this, the summary right now is way out of whack, right? It's not even close to what it's supposed to be. And I just wanted to go over that we will update that, but we have to finish this part first. My goal is that when we're all done, we make one big document, and then we go through and we sort this by HVAC, lighting, and process equipment. And then my next step would be to take all of the process equipment, highlight all these down the side, and hit grouping. So it's under, where is that? Group, right here. So we can group those. And so what happened here is I down the side here, hit grouping, and I grouped it. And now I can make it small or big, whatever I want to do. And I would typically put a line above this and put in a title and say process equipment, such that when I hit the button, it still comes up as process equipment, like I showed you that one document with all those different groupings. So that's where I see this spreadsheet going. But I do not want to get into that. I don't want you folks to do this until we're all done. Once we're all done the load inventory, then we'll all take this and we'll make it nice and pretty. But this was just kind of where we started. And I mean, the grouping really looks nice when we do this. And we can make this smaller now, and now we get a nice working document just with category and the total kilowatts and the total of percent energy and that kind of stuff. So when I went through your folks' documents, I just made sure that the information was entered as requested. The category was filled in. All of this stuff was filled in, and if it was in yellow if you didn't know or you were unsure, and that all the formulas worked and everything made sense. Now, do you folks see anything on here that doesn't make sense for Nick's document? I don't know if you can see that. I'll do this. Anything there look funny? What's that? 190 total kilowatt hours. That's like I don't know, $10 worth of electricity, right? So what's wrong here? And I only know this because I went over it last night or yesterday. Is that Nick put in this formula equals R18 times Q18. Oh, sorry, Nick, I'm kind of throwing you here, but what did he forget? He forgot to multiply by the hours per year. So he's got the percentage of the year, the total kilowatts. He just needs that 8,760. And that would bring his kilowatt hours more online. So that's what I was looking for, just to make sure all the formulas made sense and that your numbers made sense. So I red flagged this when I looked at this and said, we're not consuming nearly enough energy that we should be. And then there was the opposite. Some folks had, the number here was like it was like 22 million kilowatt hours when the whole building only used 8.5 million kilowatt hours, right? So I red flagged that. So can I kind of look at this and apply some common sense when you're going through it? Any questions on that? Where we're going to be going with that? No? Okay. Like I said, I had hoped to get up there this week. That didn't happen, so we will carry on with that hopefully next week.
Is it just going to be mainly a load inventory focus?
Yeah. The next Anthony's actually he's off on vacation next week. So I had Jonathan say, yeah, go ahead and remove the data loggers, the elite loggers, and then we can collect the data when we're there. But we can expect that the loggers now have been taken off, and we probably won't have an electrician next week, but we'll just do the best we can. The plan for today, and you'll notice this is due Sunday. I'm devoting the rest of this period to working on it, is the wrap-up of your flow analysis assignment. Okay, so it's worth 4%. Okay, and this is we did this last week, the process sketch. Your next step is to list your assumptions, right? Temperatures, flow rates, etc., etc. You need to come up with assumptions for now. Okay, we can always change the assumptions if we go up there and actually do measurements, but I'd like you to just look at it and say, I expect that it's this, and then be able to work through to solutions. Okay, as a reminder, the spreadsheets are here, the thermal inventory as well as the envelope, and the end result should look like figure 7.10 and table 7.2, and I'll just flash those up. Okay, so this was for this energy flow diagram, and even bring it back a step, here's the industrial food processing system that it really started from. This is what I had you folks complete last Thursday, except we don't have any numbers in there yet. So the numbers is what I want you to work on today. We've got to make some assumptions and then work through the solutions. I went home yesterday and I was like, how do you quantify noise, right? And the thing is, usually everything turns to heat. And you'll see that the conveyor system, well, we're losing some heat and noise from the conveyor system. And if you see here, heat and noise, which is what is labeled here, all of the conveyor energy is given off as heat and noise. Okay, the boiler, right? The oil going into the boiler, that's all the energy that goes into the boiler. And then you'll see here, so hot flue gases, how much of that is given off as heat? So assumption, 20% of the energy into the boiler. The blowdown losses, 1% of the fuel. Right? So these here are those assumptions that you folks need to make in order to quantify these energy quantifications. No, if that's a word, quantifications. Okay, so that's where we're going today. So your key thing today should be to figure out these assumptions so that you can carry forward. Okay, and I'm going to stop there. F9, I think it is.